is involved in a lot of different math. Anytime that you have circles or spheres or things rotating or, really anything that involves circular motion, pi is going to be involved in there somewhere. It is important to progress in many different sciences, but particularly astronomy, because, there's circles and spheres and spinning things all over the place in the universe. One of those big things that humanity wants to know is, are we alone? Are there more people or aliens or green slime out there around other stars in the galaxy and other stars in other galaxies? There are so many stars, and now, thanks to research in the last 20 years, we know that most of them have planets. And so I particularly study young stars because I want to understand what makes a star decide to form a disk, and does that disk form into planets? Does it do it every time? If it doesn't do it every time, why? One of the aspects of Are We Alone is, are there other planets? And in order to figure out where and when and how planets form, you need to understand the rotational evolution. I have stars that are whipping around in less than a day. So they are really flying around, and they have big spots. And so there's huge changes in the light that we get from the star every time it turns around. In some cases, we believe that we're seeing spots changing shape and forming and reforming on these stars. It's really amazing. But in order to do those calculations of how much of the star's surface is covered in spots, because we're working with spheres and circles and rotation, pi is in there. So it's just one of those things, kind of like air. It's just always around, and it's always important, and it crops up in all over the place.